This is a quick video about multiplying multiple digit numbers using place value strategies and distributive and commutative properties. If we have a problem, 4 times 30, we need to remember that 4 times, it means 4 times 3 tens. Okay? If we draw this in our place value chart, we have 3 tens, and we're doing that 4 times. If we add them all together, it means that we have 12 tens. In standard form, that is 120. Remember that we are moving the 1 into the next column and adding a 0 as a placeholder before our decimal. If we have 40 times 30, it's the same thing. We have 4 tens times 3 tens. Remember that 10 times 10 is equal to 100. We don't want to forget that. So then 4 tens times 3 tens is 12 hundreds. In standard form, that is 1,200. Okay? Another way that we can do this problem is to break it into smaller pieces. With my smaller pieces, what I really have is 4 times 10 times 3 times 10. Knowing that 4 times 10 is my 40, and 3 times 10 is my 30. I've just broken it down into smaller pieces. Now, does the problem change if I move them around so that I have 10 times 4 times 3 times 10? No, I'm still going to get the same product. I just have them in different places, or if some of them are in different places, I will get the same result. I'm still going to get 1200, which is 1200. This is called commutative property. What that means is that I can move all of my numbers and I'll still have the same result. So I can do 4 times 3 times 10 times 10, or I can do 3 times 10 times 10 times 4. It all equals the same product. The easiest way to think of this is like a commute. Okay? When you're driving somewhere, okay, you're still able to move it around and you're still going to get somewhere. This works with our numbers as long as everything is being multiplied. Okay? When we go back to the original problem that we had, it was 4 times 10 times 3 times 10. There are no other functions. Everything here is multiplied together. Let's look at 5 times 60. That is the same as 5 times 6 times 10. Because we know that 6 times 10 is 60. I've just broken it down a little bit more. We can write it with parentheses if we want. So it is 5 times 6 times 10. Okay? The parentheses here just means that that piece needs to be done first. I like that because it's easy to multiply something by 10 afterward. So we can do 5 times 6, which is 30, times 10, which is 300. Remember that using the commutative property, we can move these numbers around, so it doesn't have to be 5 times 6 times 10. And even though we originally had 60, we can move the parentheses here. Another way to look at it is that 5 times 6 inside the parentheses is already inside somewhere that you want to go. They got there first. The second part will get to go in later, but they're not there yet. It will happen soon. If we have the problem 451 times 8, we know that we can solve that using the area model. First we're going to draw a rectangle and break it into 3 sections because of our 3 digits here. And then we'll write our 8 because there's one row, 1 8. And we have 400. Remember the 400 comes from the 4 in the hundreds place. Then we have 50, which is 5 tens in the 5 tens place. and 1, 1. And then we just fill in the chart. 8 times 400. Okay, think of it as 8 times 4, which is 32, and it's 32 hundreds. 8 times 50, or 8 times 5 tens. 8 times 5 is 40, 40 tens is 400. 8 times 1, 8 times 1, 1, which is 8. And then we just add everything together, so we will have 3,248. Now that's solving it using the area model. A similar way that we can do this, instead of just using the area model, is breaking it down a little bit more. We can take our numbers, 8 times 400 plus 8 times 50 plus 8 times 1. Okay. What I'm really doing is I'm taking that 8 here and I'm distributing it to each piece. Okay. Another way to write that is if I do the 8 first, 8 times 451. I am then distributing it 8 times 400, 8 times 50, 8 times 1. Okay, piece by piece. It's the same way, but this is considered the distributive property. What if we have the problem 451 times 80? Again, we can solve that using the area model. Okay, just like we saw last time. We have 80, 400, 50, and 1. Okay, here's where it gets a little bit more challenging. Remember that this is 8 tens and 4 hundreds. Okay, so I'm going to end up with thousands. Okay, so 8 times 42, 8 times 4 is 32,000. Don't forget your comma. 8 tens times 5 tens, okay, is 40 hundreds. 10 times 10 is 100, remember. 80 times 1, okay, 8 tens times 1 is 80. Okay, then we're going to add it all together again. So we still have 30,000, but now we have 2,000 plus 4,000, which is 6,000. Okay, 0 hundreds, 8 tens, and there's my final product. Okay, we could also use the distributive property like we talked about before, where we have 80 times 451, and remember we're distributing that to each piece.